Hello, everyone. All right, so this is going to be the beginning of Unit 3. So Unit 3 really talks about a lot of graphing. So more specifically, we're going to be graphing a lot of linear equations. So just some vocab before we really get started. So we're looking at the attributes of linear equations. So we're looking at things like slope, the intercepts, different linear equation forms. So there's a few things that you need to be familiar with before we really dive in. So we have what we call the slope, which is the measure of a steepness. So what you're also going to see slope being called is rate of change. So your next thing that we're going to look at is called the y-intercept. So the y-intercept is essentially just where it crosses the y-axis. So same idea with the x-intercept is where it crosses the x-axis, but for the x-intercept, we also have a specific name for it. So we also call it the zero of a function. So as you see over here, it's just also called the x-intercept. So we're going to be looking at two specific forms of linear equations. So we have what we call slope-intercept form, and we have standard form. So slope-intercept form gives you exactly what the name entails. It gives you a slope and an intercept. So more specifically, the intercept that they give you is the y-intercept, not the x-intercept. So standard form looks just like this, ax plus by equals c, and there's actually some other attributes that we're going to be looking from standard form here in a little bit. So first off, we're going to look at some formulas, but we're going to look at the formula more specifically for slope, which we also call the rate of change. So you're going to be seeing rate of change a lot. We could say slope in terms of a rate. We could say it in terms of change. We could say it in terms of each day per hour, just anything that signifies a rate that's reoccurring. So as you've probably seen before, your slope on a graph is essentially just the rise over run. But if we want to find it algebraically or mathematically, we could also use this formula here that we have, which is the change in y over the change in x. So y2 minus y1 over x2 minus x1. So if you see here, we have this triangle. So that triangle is the Greek letter delta. It is just a math way of saying change. So when I say change in y, I'm saying delta y. Or when I say change in x, I'm saying delta x. So looking at our two specific forms here, we're going to be actually graphing, but also finding these intercepts. So we need to be able to look at what these equations are telling us more specifically. So here, we want to be able to find slope. So over here on the left side, I'm given two coordinates, and over here, I'm actually given two coordinates, but on a graph. So there's several different ways that we can do this. So first, I'm given two coordinates. So I'm going to use the slope formula to find the slope between these 2 points. So if you notice, with the slope formula, we have two sets of x's and two sets of y's. So what that is referring to is we have the first coordinate and we have the second coordinate. So you have to label. So what I mean by label is, remember, we're given some xy and we're given some xy. But more specifically, I'm going to say the 2, 1 here, I'm going to say this is my first coordinate. So what I want to do is I'm going to say this is my x1, y1. So that means my 3, 4, this is going to be my second coordinate. So this is going to be x2, y2. So I want to take each of those values and I'm going to plug them in exactly how they look to my slope formula. So I'm going to say slope equals, and I'm going to start with my formula. So y2 minus y1 over x2 minus x1. So if you ever are trying to remember which of those variables goes on top, which one goes on bottom, just remember rise over run. Rise is your vertical change, which is your y value. So the y value goes on top. All right, so I want to do y2 minus y1. So I want y2 minus y1. So I want 4 minus 1 in the top. And then I want that over x2 minus x1. So x2 minus x1. So 3 minus 2. So now I want to subtract. So 4 minus 1, which gives you 3, over 3 minus 2, which gives you 1. And then 3 over 1 simplifies to 3. So that means your slope here is just 3. Now here's another thing. Would it matter, let's say if I make this my first coordinate and this my second coordinate. Let's say I switch it up. It actually doesn't matter. So if I solve it again, but doing it backwards, so now let's say I still do y2 minus y1, so now I'm going to do 1 minus 4. That's going to be over 2 minus 3. So 1 minus 4 gives you negative 3. 2 minus 3 gives you negative 1. That simplifies to a positive 3. So even if you do them backwards, it doesn't matter. You get the same thing either way. All right, now for a graph. So I'm going to do the same idea here. The only difference is the way they present the information. So in this case, they gave it to me on a graph. So you still need to label first. So as mentioned before, it doesn't matter which one's which. So I'll say this is x1 and this is y1, and I'll make this x2 and this y2. So if I want to find my slope, so I'm still going to do y2 over y1 over x2 minus x1. So if you look, I know on a graph you could technically do rise over run. However, if you look at this graph, the scale is by 2, and if you look at those points, they're in some kind of weird places. So rise over run in this case isn't going to be necessarily helpful until you're, unless you're really careful. But I would say if the graph is really weird, has a weird scale, your points are in a weird place, I would say just stick to the formula. All right, so y2, so that'd be negative 3 minus 2 over negative 2 minus negative 3. All right, so you have to be very careful here whenever we're doing negatives. So if I'm doing negative 3 minus 2 in the top here, so negative 3 minus 2 gives you a value of negative 5. Now, if you look in the denominator, we have negative 2 minus a negative 3. So I'm going to actually rewrite this before I solve it. So I'm going to extend that. So this is going to turn into negative 2 plus 3. So what this simplifies to is I have negative 5 over negative 2 plus 3, which gives you positive 1. So negative 5 over positive 1 simplifies to a slope of negative 5. So if it was on a graph and the scale was by 1 and it was easier to count, then by all means, definitely do rise over run on a graph. All right, so now if I'm given an equation and I want to find the slope, there's actually 2 different methods that you can do. So option 1 is you can convert. So this is the more traditional way. And then option 2 is there's actually a standard form trick that you can use. So I'm going to start with converting. So what I mean by converting, I want to convert to slope-intercept form. So I want my equation to be y equals mx plus b. So what we're doing is we're going to be solving for y. We're getting y by itself. So if you think back to literal equations that we did in Unit 1, or even just aspects of solving for y, this is essentially what we're doing again. So I'm going to start with my equation. So I have 2x minus y equals 6. So I want to solve this for y. I'm going to get y by itself. So I want everything else on the other side. So I'm going to do my inverse operations. So I'm going to start by subtracting 2x. So you have negative y equals negative 2x plus 6. So I'm going to put my x in the front so that I know that's going to be my slope. Because I want it to be in slope-intercept form. So if you look, your x value is in the front, and your y-intercept is actually behind it. All right, so I still have that negative 1 right here that I need to get rid of. So with that negative, what I have here is I have negative 1 times y. So because I'm multiplying, I'm going to divide by that negative. So whenever you divide by a negative, all that means is you just flip the signs. So negative goes to positive, positive goes to negative. So I'm going to have y equals, so negative 2x over negative 1, then plus a 6 over negative 1. So I'm going to do this step by step so you can see like how it changes and what it looks like, but this isn't always going to be expected for you guys to show. So like I said before, just switch the signs. So two negatives here make a positive. So we're going to have positive 2x, and then we have plus a negative. So plus a negative is just subtraction, so minus 6. So when you're in slope-intercept form, that m value, that's your slope. So we only want the value in front of the x. So in this case, our slope is going to be 2. So one thing to note that I see happen very often is if you ever say your slope is 2x, that is not right. You do not include the x. You only want the number in front of the x. All right, so now we have what we call the standard form trick. So for this one, I'm actually going to go down here a little bit. So this is where the actual trick is. So when I do the standard form trick, so it must be in standard form. So the standard form trick actually tells you 3 of the attributes. It tells you the slope, the x-intercept, and the y-intercept. So if you look, standard form has ax plus by equals c. So the trick involves the letters a, b, and c. So those are actually going to be constants or coefficients. So down here, to find the slope, I want to take the opposite of a, so negative a, over b. So for the x-intercept, I want c over a. For the y-intercept, I want c over b. So all those, so a and b are going to be those coefficients, and then your c value is that constant at the very end. So plug them into these different little tricks, and that will help you get those aspects and attributes. So up here, to do the trick, first you have to see if your equation's in standard form. If not, it won't work. So in this case, we have 2x minus y equals 6. So in the form ax plus by equals c, we're looking the number in front of the x for your a, the number in front of the y for your b, and then the c value on the far right side. So if you look, the number in front of our x is going to be our 2 value. And if you look, we don't actually have a number in front of the y, but because of that, we assume that there is a 1. So because we're subtracting, it's going to be a negative 1. So our b value is negative 1. And last but not least, we have our c value at the very end, which is just 6. So I'm going to take all those values and just use my trick. So for my slope, so m equals the opposite of a over b. So I want to take the opposite of a. So because I have a positive 2, I want to negate it. I want to make it negative 2. So I have negative 2, and then I take my b value as is. So negative 1. So negative 2 over negative 1 gives you a positive 2. So that would be our slope. So to find the other options, or the x and y-intercept, I'll go ahead and find those as well, just so you can kind of see what that looks like. So if I want to find the x-intercept, that is your c over a. So my c value of 6 over my a value of positive 2. So 6 over 2, which gives you 3. So keep in mind, this is my x-intercept. This is where it crosses the x-axis. So I could actually rewrite this as a coordinate. So if it's on the x-axis, it's where it crosses the x-axis. You have to be careful how you write it. So this coordinate would be 3, 0. So if I write my y-intercept, Now I want C over B. So in this case, I want 6 over -1. So that simplifies to -6, which as a coordinate would then be 0, -6. So please be very careful how you write your intercepts as coordinates, because you don't want to get your x-intercept and then write it as a y-intercept, and vice versa. Okay. So now we have these different types of slopes. So we have a positive slope that is kind of going in the top right direction. Then we have a negative slope going in the bottom right direction. And then we have what we call a zero and undefined slope. So a zero slope is going to be horizontal, whereas undefined is vertical. So if you need some little trick to help you remember, so a zero slope, so I use the first letter. So with the Z, it goes left and right. So that's what I use to kind of help me remember. And then for undefined, I use the U. So the U in undefined faces upwards. So that's how I remember that it goes up and down. I mean, even math teachers sometimes use tricks to help remember things. So with that, there's another trick to also help you remember. So I call it Hoibots. So Hoibots is to help you remember the characteristics of horizontal and vertical lines. So what I mean by Hoi, so if you were ever given a y equals equation, so if you have a y equals equation, so y equals a number, then that tells you it's going to be a horizontal line with 0 slope. I can't spell, everything's fine. So 0. So horizontal, 0 slope, and it's a y equals equation. So the same works for VUX. So if you ever have a x equals equation, what that means is it's going to be a vertical line, and it's going to have an undefined slope. All right. So with VUX, it's going to be vertical, undefined, and it's an x equals equation. All right, so now if we want to find intercepts, that's where the standard form trick is going to come into play, especially with the C over A and C over B. But you also have an option to just convert. Or you could even just sub in zeros. So if you want to find your x-intercept, it's where your y value equals 0. So if you want to kind of have a visual to kind of picture y, I'm going to draw just a rough little sketch of a graph. So let's say our graph is going like this. So our x-intercept right here, it would be some number, comma, 0. So notice how the x-intercept, the y value is 0. So plug in 0 for the y value. And then you want to solve for that x value. So the same works for a y-intercept. So let's say I have my y-intercept, my b value. So this would be some 0, comma, a number. So if you look at the coordinate, now your x value is 0. So you plug in 0 for your x and solve for that corresponding y value. So if you want the visual, like this will help kind of visualize and make a lot more sense of why we're doing what we're doing. So you can also do the standard form trick, which I'm going to do both, so you can kind of get an idea. All right, so for these, we want to find the slope, the x-intercept, and the y-intercept of each of these linear equations. So for this one, I made a little note to myself to use the trick. So one thing to note is I actually give you the little entries to actually write out the slope, the x-intercept, and the y-intercept. But if you see, I won't always do that. So this is just to provide you some structure for right now. So I'm going to start off by using the standard form trick. So if you notice, I'm in standard form. So because I'm in standard form, I can use the trick. All right, so for the slope, I'm going to use the opposite of A over B for the x-intercept. I have C over A. For the y-intercept, we have C over B. So the first thing you really want to do is identify your A, B, and C value. So I'm going to actually move these down a bit. And so if you look, remember, our form is AX. So our value with our X value, the number in front, that is our A value. So we have an A value of 2. So we have AX plus BY. So if you notice, with our Y value, this is our B value. So see how we're subtracting? So that means our B value is going to be a -3. However, if this was a addition sign, then that would be a +3. But because we're subtracting, it is going to be negative. And last but not least, our C value, which is over here on the far right side. So we have a C value of -6. All right, so now I want to actually find these specific values. So for the opposite of A over B, for my slope, I want the opposite of A. So because it's a +2, I want to take a -2. Then my B value, I'm going to leave it just as it is, so -3. So if you see here, we have -2 over -3. Well, 2 negatives make a positive when we're dividing. So this is going to be +2/3. So our slope over here is 2/3. All right, so now for the x-intercept, I want C over A. So my C value is -6. My A value of +2, which simplifies to -3, which as a coordinate would be -3, 0. So whenever you're giving the answer for the x-intercept and the y-intercepts, your answers could be actual numbers, or they could be written as a coordinate. So just be prepared to look at both. So for right now, I'm actually going to write it as a coordinate, just so that you get both the number and the actual point. All right, now for the y-intercept. So we're going to have -6 over your b value, which is -3. So -6 over -3, which simplifies to +2. And as a coordinate, this would be 0, 2. So I will say using the trick does make the problem go by faster, but it's really up to you on how you want to do it. It depends on your strengths as well. So for the second one here, I'm actually going to convert, just so you guys can see what that would look like. So I still want to be able to find all 3 components. So even though this is in standard form, you still could do the standard form trick, but I'm still just going to show you what it would look like if I converted. So when I convert, remember I want it in slope-intercept form. So what that means is I'm solving for y. I'm getting y by itself. So what I'm going to do is get rid of any addition and subtraction first. So I have to get rid of this -4x. So because it's negative, I'm going to add it on both sides. So I have -5y equals 4x plus 40. So now I have this -5 over here that I've got to get rid of. So because I'm doing -5 times y, I'm going to do the opposite. I'm going to divide. So over here, I'm going to have y equals. So I'm going to go ahead and separate it out, or try to. So I'm going to have 4x over -5 plus 40 over -5. So now I want to kind of clean it up and simplify. So 4x over -5, that's going to be the exact same as -4 over 5x. And then 40 over -5, which gives you -8. So what this tells us is our slope is -4/5. Then I also want to find my x-intercept and my y-intercept. So if you look, our y-intercept is actually right here. It's our -8. So we have a y-intercept, nope, -8. But if you notice, we didn't get our x-intercept. So we still have to find the x-intercept. So if you look up here, remember for your x-intercept, we want to plug in 0 for y and then solve for x. So what that means is this y value is then going to turn to 0. And what I want to do is I want to solve for x, because now I need to find that x-intercept. Nope. So what I'm going to do is now solve this equation. So I'm going to add 8. So I'm going to have 8 equals -4/5 x. So on both sides, I'm going to multiply by 5. So I'm going to have 40 equals -4x. Divide by -4. So x is going to equal -10. So as an x-intercept, that point would be -10, 0. So this is all my information that I need. Gross. There we go. So as you can see, if I convert, it is a little bit more involved. There's a few more steps that are going to be required. But as mentioned before, the trick or converting, either way, it's going to work. All right. So looking at this next one here. So if you see, we have a slope-intercept form equation. So what that automatically means is I cannot do the trick. I cannot do the standard form trick, because remember, it has to be in standard form. But in this case, it's about as quick just because of the way it's written. So in this case, our slope is the number in front of the x, and our y-intercept is right here at the end. So I'm going to write it over here. So my slope, which is just 2, I still got to find the x-intercept, but I do have the y-intercept. So in this case, which is -4, so it's 0, -4. So if you remember, to find the x-intercept, we make y equals 0. So I'm going to bring this down. So I have 0 equals 2x minus 4. Now I want to solve it for my x value. So add 4, add 4. So I have 4 equals 2x. Now divide both sides by 2. So x equals 2. Now remember, you want to write it as a coordinate. So this would be 2, 0. So there's all of our attributes for this one. No, yeah, close enough. No, there we go. All right. So looking at this next one. So if you remember, now we have y equals 1. So if you think back to Hoibots, look here how we have a y equals. So because we have a y equals, that means that we're going to be using Hoi. So if you remember, Hoi up here means we're going to have a horizontal line with 0 slope, and it's a y equals equation. So you're really looking to see if it's a y equals or an x equals equation before you really even look. So to know when you're using Hoibots is on the right side over here. If you just have a number with no variable, like x equals 2, y equals 20, x equals pi, if you have just a constant on the right side of the equal sign with no variable, that's how you know you're going to be using Hoibots. So because I just have y equals 1, there's no like y equals x plus 2. It's just a number. So we have to use Hoibots. So because we have a y equals, I'm using Hoi. So this is going to be a horizontal line. So just to kind of give you a visual, if my y value is +1, it's going to be just right above the x-axis. So I want to be able to fill in those attributes. So I'm looking for my slope, my x-intercept, and my y-intercept. So if you remember from Hoi, the very middle, it means 0 slope. So we have a slope of 0. Now our x-intercept, if you notice, our x-intercept is way down here. It never intersects the x-axis. So what does that mean in terms of an x-intercept? Well, if it never crosses, that means the x-intercept is what we call D and E. So D and E just means does not exist. But if you look at the y-intercept, you see it crosses right there. So if you look, it's literally just the number itself. So in this case, the y-intercept would be 0, 1. All right. So let's actually jump over here to this one. So now we have a x equals -3. So because we have a x equals, notice how we don't have any variables, it's just a number, so that is your indicator, is going to be Hoibots. Because we have a x equals, we're going to be using vux. So vux is vertical, undefined, x equals. So I'm going to give you guys another visual, just to kind of see what's happening in this graph. Try to. If notability would work, that would be beautiful. All right. And everything's gone. Everything's fine. There we go. All right, so we have x equals -3. So at -3, I want to draw a vertical line. So remember, on your x-axis, so -1, -2, -3. So it's about right there. Close enough. All right. So I'm going to find the slope. The x-intercept, and the y-intercept. So if you remember from Vux, our slope here is going to be undefined. So your x-intercept, so it's going to cross the x-axis exactly at that number. So our x-intercept is going to be -3, 0. And kind of similar situation, here's our y-axis. It never actually crosses the y-axis, so that means your y-intercept, in this case, does not exist. So these Hoibots problems are hopefully going to be your easy ones. You just have to be able to recognize when to use it. So remember, if there's no variable, that's when you know to use Hoibots. Whenever it's an x or y equals and it's no variable, just a number, that's when you're using Hoibots. All right, so now for your next equation over here. So you have the option. You can use the trick or you can convert. Personally, because this is in standard form, I'm going to take advantage of it and use the trick, because the trick is quicker. So what you should do first when you're doing the trick is identify your A, B, and C value. So in this case, your A value is 3. Your B value, there's no number in front of the Y. So in this case, there's a 1. So your B value is 1. And your C value would be 3. So I would say pause here, take a second, find those x-intercepts, find the y-intercept, and find the slope. Okay, So for your slope, I'm going to take the opposite of a over b. So the opposite of a, so -3 over +1, which is -3. So now for my x-intercept, I have c over a. So my c value of 3 over my a value of 3, which is just 1. So as a coordinate, this would be 1, 0. And last but not least, my y-intercept, which is c over b. So that'd be 3 over 1, which is 3. And as a coordinate, this would be 0, 3. So you can actually write out your information like this if you want to as a list, or if you want to leave it as an actual little highlight box, you can. I will take either one. Okay, so now we want to actually write these equations in slope-intercept form. So we found the attributes, now you need to put it together and actually form an equation. So when I say form an equation, we want to write it in slope-intercept form. So think of the name slope-intercept form. We have a slope and we have an intercept. But more specifically, we have a y-intercept. So in order to write an equation in slope-intercept form, you need a slope and a y-intercept. Don't think too hard about it. It's literally in the name. All right, so I'm given these 2 points on a graph, and I want to write an equation. So notice how they don't give you literally anything else. So you need to find the slope, and you need to find the y-intercept. So in this case, the x-intercept is not going to do us really any good. So there's really no point in finding it. All right, so first thing I want to do is I want to find the slope. So when I say slope, I'm going to label the points. So x1, y1, x2, y2. So if you remember, it literally doesn't matter how you label. I probably labeled them backwards from what you probably have. So if you remember your slope formula, nope. y2 minus y1 over x2 minus x1. So y2, which is -3, minus y1, which is +3. So I want -3 minus 3. Now my x2 minus x1, so I want 0 minus 5. So when I subtract -3 minus 3, it's going to give you -6. 0 minus 5 gives you -5. So when you simplify, you get a slope of 6/5. Now, if you look at your graph, now we need to find the y-intercept. So in this case, we're looking to see if we have 0, a number. Well, good news for us, we do, which means that value right there is going to be our y-intercept. So this right here is our b value. So I just need to write my equation in slope-intercept form. So y equals mx plus b. I just found my m value. So 6/5 x minus 3. So that's our equation. All right, so now over here, same idea. So in this case, I don't give you a y-intercept. I just give you 2 random points. So these are just 2 random arbitrary points. So I'm going to find the slope first. So what I'm going to do is label, so x1, y1, and x2, y2. So I will say this, because I don't give you the slope and because I don't give you the y-intercept, this problem is going to be a little bit more involved. There's going to be more steps to this one. So for the slope, so y2 minus y1, so -2 minus -7 over 2 minus 12. All right, so the numerator, it's going to turn into -2 plus 7. That's not right. Over 2 minus 12. So -2 plus 7, it's going to give you +5, and then 2 minus 12, which gives you -10. So when you simplify, this turns into -1/2. So now that I have my slope, now I want to actually find my b value. So I'm going to start off with y equals mx plus b. So I want to plug in my slope. So I have y equals -1/2 x plus b. Now, if you look, we need that b value. We don't have a b value yet. But if you notice, they gave us 2 coordinates. So they gave us an x and a y. Now look at your equation. What else do we have? An x and a y. So what I'm going to do is I'm going to take one of my coordinates and I'm going to plug it in for x and y. So I'm going to look for my smallest numbers possible to keep the math simpler. So I'm going to use 2, -2. If you want to use 12, -7, you can. You go for it. But I want to keep the math as simple and as easy as possible. So for my x value, I'm going to plug in 2. For my y value, I'm going to plug in -2. So I'm going to have -2 equals -1/2 times +2 plus b. So if you notice, now we can solve for that b value because it's the only unknown that we have. So I'm going to have -2 equals -1/2 times 2 gives you -1. So now I can solve for b by adding over that 1. So I have -1 equals b. Or if you're OCD like I am, it is b equals -1. All right, so in this case, I'm going to take my slope that I just have up here and my b value down here, and I'm going to combine them into 1. So I'm going to have y equals -1/2 x minus 1. So this is the equation. So as I mentioned before, this one does have a few extra steps, but still not as terrible as it may seem. All right, so same idea down here. So we still want to find the slope-intercept form equation. So in this case, now we have a standard form equation, but I want a slope-intercept form. So what that means is I want to solve for y. I want y by itself. So I'm going to get rid of everything with y. So I'm going to subtract 4x. Try to. So we're going to have 3y equals -4x plus 12. So now divide by 3. That's a 3, I promise. So y equals -4/3x plus 12/3. So I'm going to simplify. So -4/3 x plus 4. Why is my handwriting so terrible? Everything's fine. All right, so actually something I just thought about, you actually have another option. For this, you could actually do the trick and you could find your slope and your y-intercept, and then you could just do it that way. So if you want to do your trick and just not find the x-intercept, that also works. So a over b, or opposite of a over b, so -4/3, so there's your slope. And then your y-intercept is c over b. So 12/3, which gives you 4. So then you could have your slope and your y-intercept. So it actually works either way. You could technically do either one. Okay, now for this next one. So I give you a table. So if you notice, hopefully you notice, look at what's happening with the x values. Notice how they're all -2. No matter what the y value is, they're all -2. What that means is this going to be a Hoibots problem. So in this case, because your x value is constant, then that means it's going to be an x equals equation. So it's just a vertical line at -2. So this would be your equation. All right. So now the amazing function notation is coming back. It will forever haunt us. Everything's fine. So with function notation, remember, you can rewrite these as coordinates. So if you remember, we have it in the form f of x equals y, because remember, f of x is the same as y. So I'm going to rewrite these. I do not want a curve. There. So f of 0 equals 5 is the same thing as writing 0, comma 5. We're going to pretend that arrow is pointing to that 5. All right, then same thing over here. Close enough. So this is going to be 2, comma 7. So now we want to find the equation that goes between these 2 points. So luckily for us, this is also a y-intercept. So this is your b value, which means the only thing we need to find is the slope. So I have my x1, y1, x2, y2. So to find the slope, once again, y2 minus y1 over x2 minus x1. So here's another thing that I will say, just a bit of advice. If you write the formula consistently over and over and over and over and over, eventually it's just going to become second nature and you'll have it memorized. So you won't have to remember which one's in the numerator, which one's in the denominator. I would just say take some time, just consistently write it out repeated times, and eventually it'll be so immersed in your brain, you will never forget it. All right, so for the y values, so I'm going to do y2 minus y1, so 7 minus 5. And then x2 minus x1, which is 2 minus 0. So I'm going to have 7 minus 5, which gives me 2. 2 minus 0, which gives me 2, which simplifies to 1. So what that means for my equation is I have y equals mx plus b. So y equals 1x, and then my b value of 5. So here's the thing. This 1 right here out in the front, you don't have to write it. So our equation here is just y equals x plus 5. So if you prefer to write the 1 in the front, you can, but I will say on assessments, on literally everything else, like on a test, there's not going to be a 1 there. So if you want to write it on your homeworks and whatnot for right now, go for it. All right, and over here. Now we have a table. So if you remember, f of x is the same as your y. So these are your y values. So if you look, we have 0, comma, a number. So once again, this beautifully worked out to be your b value. So now I need to just find the slope. So from a table, it doesn't matter what 2 points you use to find your slope. You can use the first 2, no, or you could even use like the last 2. So it really doesn't matter. But as mentioned before, I would say look for the smallest numbers possible, just to keep the math simpler. So for my x value from 0 to 4, this is plus 4. From 3 to 6, so my y values, this is plus 3. So my slope here, delta y over delta x, which is change in y over change in x. So my change in y is going to be my 3. Whereas my change in x is going to be my 4. So please be careful that you're double checking to make sure it's x over y. I've seen so many people write 4 over 3 here just because they're not paying attention. All right, so I have my slope and I already have my y-intercept, so I just have to write my equation. So y equals mx plus b. So y equals 3/4 x. Then my y-intercept, which is positive 3. Boom. So you can see any number of these problems on your practice read on an assessment. Okay, so for word problems, this is just to get some practice writing equations out. So we're not actually solving these, we're just writing equations. So a recording studio charges musicians an initial fee of $50 to record an album plus an additional $35 per hour that the studio is used. So if you remember, I'm going to do this over to the side. Y equals mx plus b. So your m value here, your slope, this is going to be any rate. So emphasis on when we said rate of change. This is what they would charge per day, per hour, per minute. Just any rate, per mile. That's a rate. Speed limits are a mile. No, speed limits are a rate. English is very hard. So your b value, this is your initial. So like for a bank account, if they started off with like 500, the 500 would be your b value. If they're taking a road trip and they had like a 50-mile head start, the 50 miles would be your initial. Okay, so going back to your problem here. So it has an initial fee of $50. So when I say initial, this is your b value. Now, plus an additional $35 per hour. $35 per hour. So your key word here in this phrase is per. It indicates that this is a reoccurring, it's a rate. So that means this is going to be your m value. So your equation here is y equals 35x plus that initial value of $50. So that's your equation. So same idea here. So an employee makes $975 per hour working at the local grocery store. So if you notice here, we see the word per again, which means this is your m value. Now, if you notice, whenever you're an employee anywhere, you don't just walk in and automatically have like $50 in your pocket. I wish, but structurally it doesn't work that way. So in this case, if we don't have an initial value, your initial value is just 0. So what this means is you have y equals 9.7, that's not a 7, 9.75x plus 0. So when you're writing your equation, you don't need that plus 0. So it would just be 975. Do it again. 975x. That's a funny looking x, but it's okay. Listen. Thank you. All right. I would say try these next 3 on your own. So just stop here and try them. Or if not, that's okay too. So Warren has $400 and spends $22 per week on gas for work. So he has $400. So this is what he's starting with. So this is his initial amount. So this is your B value. Now notice here, it says per. That's a highlighter. Per. So this is your rate. But notice how it says he spends 22. So in this case, think of it in terms of a cash flow. Is he losing money or is he gaining money? If he's spending money, it's money out of his pocket. So he's not saving, he's not gaining. So that means this is going to be a negative slope. So in this case, our equation here, we have negative 22x plus 400. So he's starting off with 400 and he's losing $22 a week. Okay, so a pool is being filled at a rate of 5 cubic feet per minute. So think of it this way, whenever you have a pool, if you have a pool, maybe that's fine. Whenever there's a pool, you don't just start off with water. It's going to be empty, hopefully. So in this case, kind of like before, up here with number 2, we don't have an initial value. So our initial value here is going to be 0. But think about the volume. It's being filled, which means it's going to be going up, which means it's positive. So we have 5 cubic feet per minute. So this is your m value. So your equation here, it's just y equals 5x. All right, last but not least, why is there a mark down here? Go away. Okay. So now we have 775 cubic feet. English is really hard. A 775 cubic feet pool is being drained at a rate of 5 cubic feet per minute. So now essentially, similar to up here, but now it's just being drained. So instead of it being filled, now it's actually losing volume. So because it's being drained, now our slope here is negative. So we're starting off with an initial volume of 775. So your equation here, so y equals negative 5x plus 775. So there is a very distinct difference. So let's say you wrote the equation y equals 5x plus 775. If it's positive, that means you're actually filling up the pool more. But when it's negative, you're saying you're draining the pool. So really those mathematical symbols here, they matter and they make the entire problem have a different context. So you have to be careful with how you're writing your equations. So we're not filling the pool is being drained. So you have to look at these signs. They make the world of a difference.